So hi everybody and welcome back to C++ tutorial series for absolute beginners. This is video 101 and in this video we are talking about function recursion. What is a function recursion? It's very simple. It is a function who calls it itself again in his body. Let me show you an example. Let's create a function first. So I create a void function. To name it, I call myself. And here is the definition. And I said a recursion, I said a recursion is a function who is calling itself. So I write this call here in its body again. I call myself. So, but we have to set some conditions, or this call myself will infinitive loop. And an infinitive loop will crash. And let me demonstrate you this one. I crash this. And you see I have defined this on top, which means I can call it here without a for declaration. So I can just call it here in my main. I call myself. Perfect. And now I get a crash. At least almost a crash. And we go in. And you see here it says unhandled exception, and then in first person access stack overflow, and we created a stack overflow. What is a stack overflow? A stack overflow is something technical behind the scene, how the computer is allocating storage and something like that. We will skip that because you can read, of course, this one, and it becomes later actually very important to know this. But this is more theoretical and not so important for a beginner, at least at this point. But what you should know is a stack overflow means the storage is too small, and now this function acquired so much storage that it can't handle it, and that's why your PC crashes. In this case it's not crashing actually, because this one was still caught by the compiler, right? The compiler has something did here. It realized this call here, and then it still stopped this one here. But if you have something like that out, a released program, it will probably crash when it was compiled and was not realized during compile time. So that's why that's good that it's not crashing here, or I could not go on recording this video. So we have to create here some definitions, and the definition is, what's that? I don't know what this is. Let's stop this here. So the definition is, I must set a condition, not the definition, sorry. I must set a condition that this one stops. So, and how I can set a condition, for example, I can call change this definition with a counter. I say here is a int count variable, and if this count variable, for example, reaches, let's say 0, then this self call should stop. How I can make this? I say if, now I wrap this self call in a if statement. We wrap it, and or you can just call it, you just put it in a if statement. If count variable, which I declared inside this parenthesis, is, let's say, is greater 0, and then of course our count variable must be greater 0, so we can start. If it's already below 0, this will not be called. Then we can call ourselves. All right, and now of course I have to make this one here too. Oh, why am I not doing this one? And then we have, of course, change this here too, and we set this one count variable. And here is one thing missing, and of course we must anyhow decrement this count variable. So what we are going to do is here outside of the loop, I write here count variable. And now we repeat a little bit shortcuts. What was this here? Minus equal means what? It means it's subtracting itself and with 1. So this is just a shortcut, just a reminder. This operator here is just a shortcut for count variable assignment to count variable -1. I made this only for a little bit repetition, and we continue. So now this one will work almost. Of course, I must write here the argument, and here I have to create actually an integer because I want set here the start variable. Let's call it start variable. Int start variable, and we have to initialize it. At least I initialize it at start, for example, with 1000, right? And then I and call it with 1000 here because, oops, not 1000. I use the start variable here, and I know it's 1000, so that's okay. And now that can work, but let's do one more step. So this one is not very visible. Let's make it visible so that we can see something, and we know how we do this. We are just printing out after each iteration something, and what we are going to print out is here std cout our count variable. Perhaps this one, right? So we can see how much we count, something like that. All right, count variable, and let's make here a space, perhaps comma and new line, or not a comma, just a new line. All right, I hope so far it's all clear, because what I created here on top is just a normal function definition, no return type, normal int parameter, which is our count variable, and here I'm creating a normal declaration. Here I call it, and that will be printed out, and let's test it and see what we have. And yes, it counted from 1000 till 0 down, and till 1, because 0 was not included. If you want to include 0 as well, then you have to say here what we have to do. It's a very easy change. Where is this? Here we make here an equal sign, greater equal. You can make this one. Or let's say greater -1. It's also possible. So, and then you have it. Then it's a 0 included. Here reminder, not a reminder, but let's say why I put this here in top, because I have here the definition. That's why I don't need here a declaration. If you want, put this here down below main so that your main is on top. Then you have again user forward declaration. Let's make this fast so that we do repeat this as well. Now I need this declaration on top so that the compiler knows, yes, this function exists here, and now this works also. So we repeated this as well. But let's concentrate us now for this recursion function. When it's called, and it's called itself, it is similar to a structure which we already know, or even to 2 or perhaps 3. And think about it, what we know, and it is similar to this self call. Tip, it's a loop. And which loops we know? We know a while loop, we know a for loop, and we know even a do while loop so far. And yes, which means we can actually change this self call function to a loop, because you see we set here a condition. A loop has also a condition. For example, a while loop has a condition. It has a start variable. Yes, my start variable. Our while loop has also a start variable. And let's do it. Let's create this one as a while loop, because there is something interesting what I have to show you. And that's why we make this now fast to a while loop. And how we are convert now this code to a while loop, let's do it. And we can do it here, or we can do it in a separate function. Let's do it in a separate function. Let's call this function, for example, void let's say recursion function converted to while loop. It's a very long name, but it's descriptive. I read it one time, I know it, and I don't care it. So, and let's set here the while loop. So what we need for a while loop, we need a start point. Yes, I have here a start point, so I can use this one. Perhaps I set this one to global, so I have global access. Why not? Then I can access it in the function here below as well, instead in main. That's okay. Let's set it to global. Now this one is accessible here as well. Now I put this one, I can put it here, but I don't have to put it here because the while loop will be set up here in this function. Let's set up the while loop while the condition is our start variable. Okay, then we say start variable is greater, similar like this condition here, greater than -1. Oops, -1. I want loop, right? So we repeat a little bit a while loop again, and then in a function that's a little bit new so far. And let's continue. So, and now how I make this one that it's doing the stuff what we want to. Actually, we need just this one here, say out, because this is the body more or less. It should just print this one out. And we have here not this count variable, which is here, this one here. And so we have to get this count variable, or we create a count variable if we want one. But in what we can do is we don't need this actually, this count variable, because this count variable is just what I called here. And if I want this while loop here, just loop it and do it something, I don't need this count variable. But if you want really a count variable, like this function here on top, let's see what we can do there. You could do something like the count variable is passed here, and you see the count variable is actually just the start variable, right? And which means if the start variable is the count variable, and you want that the start variable is all the time printed out, you just say start variable here. You copy this start variable here. Oops. Copy this one here and print it here. Because the count, like I said, the count variable is the start variable in this case here. Because here we passed it in a function. That's why we had this one here. And here we don't need it. This is a while loop. So I hope that makes a little bit sense. And if not, watch this a little bit again, but I think you will figure it out. And let's continue. So I have now my start variable, which is this count. So I made almost all things right. There is one thing missing perhaps. And what is that? Let's see. And it's print out. Yes, we have of course set this counter, right? We have here a counter. Let's do this as well. Let's copy this one, and we set this one here too. After this one, to count variable. Okay, here of course again with a start variable. Oops, Control Z. Here we write again start variable because start variable, and now this one should be the same like this one. And one more thing, because I did it here on the bottom, of course. Now I need a forward declaration. Let's copy this at least here on top. Now I have a declaration. Good. And the compiler knows now that this function exists. And now I can uncomment this one to see if we get the same result like the other one. And I'm just calling this one here and put it in my main, and I paste it in. And I need here a semicolon, save this one, and let's see, that looks very good so far. Now we have here the functions, the two functions we created, and we can test it. Let's see if I have made some mistakes, but it looks good. And we have here the 0 and we have 1000. So we figured out a recursion function we can convert in a while loop. So they have this almost this exact behavior, but they are not similar. Careful, they have just similar behavior. You can make it this way or this way, but if we can use a while loop, we can also use a for loop. We learned that we can convert this as well in a for loop and probably also a do while loop. So now that's interesting to know, but the question is, okay, we have now so many options. Why we need a recursion function? Why is it there? Before I answer this question, I want to show you something very, very interesting, and that is, let's make this one little and this one as well little. Let's uncomment this one here and comment our while loop. And now I said, so I start here again with the normal. You can see, no problem, right? I have a function call recursively 1000 times, no problem, all numbers are there. But look what happens now. I change the number to one more, which is now 10,000. The start variable is 10,000, right? And now look what happened. And bam. Oops. What's that? And when we read here, it says exception unhandled. So there is an exception, unhandled exception, kernel-based DLL anywhere there. And it says again, stack overflow. And when we clap this out, there are some more informations. So we have a problem. We have here an exception which is not handled, right? But wait, we know how we can handle some errors, right? We learned this as well. Let's try this. What was the keyword for handling errors? It was called try catch block. So let's repeat this one as well and see if I can handle this error, which means if this happens again, I want that the try catch blocks catch this error and say there was a problem, but you can go on, because in this case I would not go on. I have to stop this code here. It would be a crash normally. Stack Overflow means most time a crash. And that's why I stop here and say, okay, you make me a problem. So in my, not in the definition, of course, here in my call, then I say I put you in a try catch block. All right, let's do this. We wrap this function in a try catch block. Try this one. This is the first part. We learned this, right? We put this one here and then control set this not. And then we catch this with an arrow, right? So, and I don't know which specific arrow this is. That's why I use the default one, which is catch any error, right? We know this. If I put here this one here is a specific error. Of course, you can use also this specific catch, and I have it down here already. Let me get this one. Yeah, let me get this block here. This one here. Copy this one. So I show you the both catch blocks here instead of only the one. And I put this one here. I uncomment this one here. And now I have a catch. And I have again a catch, which is, let's make here a format first. All right. And this one we learned is a catch with an exception. And interesting is when I showed you this one, this try catch block, we have not discussed functions, but now we know functions. Let's repeat this try catch block also. So what happens here is this catch block has a condition which is okay, this one is a function, but it is still not that what we know. This one we still skip, but I hope you know at least this part here, right? This part here is the const reference again with the class exception, which means they just won't copy it but not change it. Just remember this, and that's it. So it's a normal call. And yeah, so we have this one, and then actually this is just a variable here. Right, local variable, yes. Okay, you should know it. I was wrong. You should know this line here, because this one is a local variable and this one is a const exception reference, which means, like I said, we won't use this variable here, but we want not change it. So backward changing. All time careful with this reference here. And yeah, let's continue. So that was this catch block, and if this catches, it will print out this message here. And here, this one we have not discussed. That's why I wanted to skip it, because this one is accessing a class with this dot here. But let's skip this part here. This means just it is asking what kind of exception we have here. This what here. Here is a function call, but in a class we have not discussed what a class is so far, but no worry, it is just a function call and says what kind of function. So the next thing is here catch. It says, okay, if this worked not out, then it will go here and I catch anything. So any arrow I will catch, right? We learned this one is catching anything. And if this one is go here, I print here again this std exit 0. And this is interesting. Now where we learn functions, we understand this one too, right? This one is standard library. The standard library, this one is the resolution operator, which should search this function here. This is a function call. Indicator is also a little bit this yellow color, but hover over this function and then you can see it a little bit more in detail. It says void, okay, this underscore c decal you can ignore right now, and then it says the function and then int and then code. So it expects an integer variable, and we I put here 0. So we are understanding this one as well now. So we will start to understand slowly but steady all other codes with functions and so on. And if we learn more, we will understand more, and soon we will understand all. So let's continue. So I have made this try catch block. We understand now these functions. And when we use that try catch block, because we want test and there's something, test a code snippet. For example, here I want test this function. And if something happens, give me a handler. This exception, this catch block is a handler, right? And now what I'm going to do is I start, and now look what happens. Bang! It still not worked. At least not like I wanted. Now we are anywhere in a new page. Interesting. So before we was not in a new page, but now we are in a new page, and look what it says here. It is a file name called check anything stk, but interesting is this ending here, .rsm. And if you read rsm, it means assembly. So this has nothing to do with our C++ anymore. This is a assembly language included here, and showed that this assembly found here a problem. So this try catch block has anyhow this kind of file. It says it's a C stack check-in routine. So it comes from the C family. we are using C++. This is C stack routine, and this routine means we have here a checker, and the checker is written in assembly code. So this strange code, what you see here, is assembly code, and this one here. So we have not to understand it. What I want to point out is more, but only that you see this one time more also. Only that we should know is that this try catch block is not catching this error as well. So we have a big problem now. So this is not really catching this error, because it is catching here in a way, but let's say this would still crash if you compiled it and used it anywhere. But good, it is not compiling right now. But the problem is this code could compile in the first try. For example, if the number is here 1000, right? This would compile perfectly. But anyhow, later through an update, the variable can be changed to 10,000, and this program what you wrote could make a crash, a stack overflow in this case. And a stack overflow is hard to catch. Better said, with C++, it's not even really to catch, only if you make some preparations so that this variable will be never assigned higher than a certain in a certain range. For example, never goes to 10,000. So you can make here a preparation for that one, that this variable can't be changed or something like that. But if this variable is changed and this is executed with a recursion function, it will crash. That is terrible. That is danger, and we have a big problem. So that we have to be aware of. The next thing is what I want to show is, let's see if this is crashes as well with a while loop. That's interesting, right? So let's do here all these things in a comment. Control C, and we comment this out. And now let's test this one. Perhaps this one is also crashing. Then we have a problem. Oh, I start again here. My start variable is again 1000. Here is my loop this time. And now I start this function. And let's see if this is crashing too. And it works, and it works. So what we see now is something interesting. This loop actually worked, but this recursion worked not. So you see something here very, very important. A recursion has a limited stack. Not a limited stack size, that was wrong, sorry. The recursion function, all time when you call a function, it will call, let's say, storage on the stack. It will create storage or occupy storage on the stack. And if this is happening, the stack has a limited size, and this stack overflow is happening. This arrows, what I showed you before here in this loop, which we even can't catch. And on the other side, this loop here is not creating this one. So I create here one function. This one is going to the stack again, but this loop here is not creating there, occupying any new sizes in the stack, which means here I can just run this one here easy, and it's not crashing. So that's very important at this point to know. And then the last question is, wait a minute, if we have a loop, and we can even use a for loop or other things like that, why the hell we should use at all this recursion, right? Because this is danger. This is filling our stack, which will probably cause even more problem if we can't load other parallel files or something like that in stack. Why we use this kind of recursion at all? And the answer is, there are special cases where they use this kind of functionality, because it makes it easier. It makes it easier to handle. And yeah, that's so. There are not many cases, but there are really special cases where this one is used. And let me show you here in Wikipedia one case. And you will see this definitely in the computer science. You will hear it or anywhere. It is this tree. If you hear tree or graph, it's similar to this one. If you hear tree, then you know that is the place where they probably use recursion. And the reason for that is they have some call behaviors. And I'm not going over now through what tree is. You can read here a little bit tree and read a little bit more, and then you will see they will use to solve this problem, this tree problems. There are different kinds, this recursion thing. All right. So, and here I want to show you here a little bit more, some more, let's say, non-mathematical example, because recursion, you will find many math examples. You can forget them because if forget them only if you have not to use anything with math. If you are going to program normally, then you are not really using this kind of recursions, but other recursions you will use. For example, interesting for a programmer will be more this file system. Yes, they are using in a file system, or interesting for a programmer will this dictionary structure. Dictionary structure means, for example, you search a word, let's say co-reference, the word co-reference in another language, and this is like a dictionary. So you search it, and how they implement it is probably something to do with recursion, but not really, not necessarily. It is optional, depends on the if they really make it, if they get an advantage with that. Most time they get. And yeah, nested sets, and you can read this here a little bit more and read about recursion as well, because there are not many cases. And most time when you hear recursion in computer science, they start with math examples. I wanted to skip that because this math examples is more traditionally comes from, let's say, to explain mathematical concepts, which is not here good for beginners, I think, because then you have also understand mathematical concepts, which is more confusing at start. So concentrate more on the basics here, that we can call a function ourselves, but it will fill up the stack, which can cause Stack Overflow. And if you hear Stack Overflow, you know the site, for example, Stack Overflow. This is a helper site, but what I mean is, if you hear Stack Overflow, this is also a signal word for hackers, right? They are using old-time a concept with Stack Overflow to get into other machines. Of course, not directly. There are much more preparation, but one way is to cause a Stack Overflow and then use this as an exploit and so on. So there are dangerous things with the Stack Overflow, and here is an example how to create definitely a Stack Overflow. And you see this crash was caused because a Stack Overflow here in this case. And yeah, I think you have to read a little bit about this one again in theory. Read also about this tree and graph. Perhaps you don't understand this so well if you not go to university or something like that, because they are using here again formal language. You can skip this also and concentrate only on this programming part here, that you can call a function. The only thing which you really need is you can call yourself and call it not too much. Perhaps this one, because you have checked your stack size, and there is also ways to check the stack size and then limit this variable how often you can call yourself. That's one preparation, but like I said, this can be changed with an update and still crash in the future if you are not careful. Yeah, it's danger, but there are other solutions probably, and they will come. We on the other side will probably use very less recursion. Instead, we are using these loops here, this while loops, this for loops. This one we will use many times, 1,000 times, million times, instead of this self-calling functions. Only if there are special cases. So with that said, I will stop this one here. And yeah, I hope it was not too confusing, but this will encounter you sometimes too, and you should know this. With that said, if you have any questions or complaints, like all times, write it in the comments, and see you in the next video, and bye.